On this video, we're going to look at magnetic and non-magnetic materials. I hope you guys do know magnets. We use magnets a lot in attracting metals, especially when we were kids. We used to check how real is the money by using magnets, but now I don't know if you guys still do that. So magnetic substances, they can be magnetized and attracted by other magnets. They're called ferromagnetic substances. For example, your iron, nickel, and cobalt. Where are they used? They're used in compass, electromagnets, in cranes for removing scrap metals, fridge magnets, telephones, and radio antennas. Non-magnetic substances are those that are not attracted by magnets. For example, copper, manganese, and tin, glass, wood, and plastic. Okay, so you need to know all these things from what I taught you in metalloids, from what I taught you in metals, metalloids, and non-metals. You should know the properties, you should know the uses, and you should know where we find these in the periodic table. And also you need to know the electrical conductors, the semiconductors, and the insulators. Also you need to know the magnetic substances and non-magnetic substances. Okay, so we talked about thermal conductivity, but I didn't really tell you how you can test for thermal conductivity. Remember, thermal conductivity is how good a substance can conduct heat. So what you can do is you can take a substance that you want to test and then put a piece of wax on one end of that substance and put the other end of the substance in a beaker with hot water. So the faster the wax is going to melt, the better the substance is at conducting heat. So you can do this if you have wax, if you have a metal that you can test, maybe you can do this. And I have 5 end of chapter example problems that we will do together. So question 1 is about pure substances and mixtures. I have a table here that you should complete to determine if a substance is a pure substance or a mixture, and if it's a pure substance, further classify it as an element or a compound, and if it's a mixture, you should say whether it's a heterogeneous mixture or homogeneous mixture. So number 1, we have the chlorine gas. A chlorine gas is a pure substance and it is an element. And then a diluted acid is a mixture and a homogeneous mixture. Steel is an example of an alloy, so it is a mixture and a homogeneous mixture. Table salt, it's just NaCl, it's a compound, so it is a pure substance. Magnesium ribbon, this is just magnesium in a shape of a ribbon, so it is an element and it is a pure substance. Coca-Cola, I hope you remember the mixture of carbon dioxide and water, so it is a homogeneous mixture. Air at a factory plant, so this is a mixture but a heterogeneous mixture, because this is not like the air found in the atmosphere. It is because in a factory you can even see smoke coming out, so, and sometimes you can even see smoke of different colors coming out, so that is a heterogeneous mixture. Then question 2 is about valency and symbols of ions. So the first question says, how do you work out the valency of an atom in groups 5 to 8? So remember how you work them out. You say group number minus 8. So now we can use that to write the valency of nitrogen. So nitrogen is in group 5. So what's the valency? It's 5 minus 8, which is minus 3. Then we have aluminium. Aluminium is in group 3. So its valency will just be its group number, because remember, from group 1 to group 3, how do we work the valency? We just take the group number. Then neon is in group 8. So how are we going to work that out? We're going to say 8 minus 8, giving us 0. Iodine. Iodine is in group 7. How do we work out its valency? We say 7 minus 8, which is minus. Okay, now question 5, which should be question 4, but it's okay. So now writing chemical formula of compounds. Chemical formula for copper 2 sulfate. First, we look for the valency of copper, which is positive 2, and the valency of sulfate, which is minus 2. So the anionic table that I taught you earlier now is coming in handy, because you have to know that the valency of SO4 is minus 2. So the two charges add up to 0, so the formula could just be CuSO4. Mercury 2 chloride is written as HgCl2. Why? Because the valency of mercury is positive 2 and that of chloride is minus 1. So using the crossover method that I taught you, you get HgCl2, because then you are going to need one ion of mercury and 2 ions of chlorine. Sodium hydrogen carbonate. Here you just need to know what the formula for carbonate is. Again, you should visit your tables, your anion table and your cations table. You're gonna find all these compounds that are important for exam purposes. And then phosphor 5 oxide will be P2O5, because phosphor 5 means that the phosphor has a valency of positive 5, and we know that oxygen has a valency of minus 2. So then using the crossover method again, you're gonna get P2O5. Ammonia, you should know that ammonia is NH3. So you should visit your table of compounds. Silver bromide is AgBr, because Ag, silver, has a valency of +1 and bromine has a valency of -1. And then question 4, which should be question 5, naming compounds. So how do we name Li2O? First of all, we look at the different elements that make up the compound. So we have 2 lithiums and 1 oxygen, but we would not write dilithium oxide, because remember I said the prefixes, they only work in monoatomic anions. And then we have AlNO3. This is going to be aluminium nitrate. Again, this will not be aluminium trinitrate. Why? Because nitrate is not a monoatomic anion. Like I said, the prefixes only work in monoatomic anions. Then NO2, so here O2 is a monoatomic anion, so O is a monoatomic anion. So here we can use the prefix nitrogen dioxide. HgCl, what is Hg? It's mercury, Cl, chlorine, so it is going to be mercury chloride. That is it on this video. So in the next video, we're gonna start our new chapter where we'll be looking at states of matter and the kinetic molecular theory.